Hello. So I'm here actually today to discuss geopolitics and geopolitical competition with respect to nanomaterials. So much less academic, much more commercial. So just as a quick introduction, again, I'm Landon Mertz. I'm the CEO of Cerion Nanomaterials. Our company in the United States is one of the largest for designing, scaling, and manufacturing nanoparticles. They tend to be metal, metal oxide, and ceramics. And as a company, we support basically 40 broad sectors, mostly mid-cap, large-cap companies across the US and the EU. And what we're doing is we're working with product development groups in large companies to help them commercialize nanomaterials and bring them to market. It also happens to be that I am the chairman of the Nanotechnology Industries Association. This is a group that's focused on both trade and regulatory policy within the nanomaterials industry globally, but really with an emphasis on the EU and the US. If you're a commercial company and you're not currently a member, I really would highly encourage you to check the organization out. And Sean Kelly, who's their Director General, is here today if you'd like to talk to him. So today, I really want to address what I believe is one of the big elephants in the room, and it's something that I believe is going to have profound implications, both for the European Union, but also the United States well into the 21st century. And that's really the question, how do we compete going forward? And specifically, what are the economic, the defense, the foreign policy implications of winning the global race for general purpose technologies? So if you'll indulge me, I want to talk a little bit about the current state of play. And as it happens every 100 to 150 years, the tectonic plates of economics are shifting, and really by extension, geopolitics. And we're beginning a transition now from a unipolar world where the United States is the dominant player to a multipolar world. And of course, what I'm really talking about is the rise of China as a peer competitor to the United States. And what we see in the news every single day is that there's a fierce competition happening across a wide variety of vectors, things like defense, foreign policy. But very little attention is being given to what I think, in my opinion, is the most crucial and critical areas, and that's the competition for supremacy in new technologies. And specifically, general purpose technologies. Which is my focus. And as we all know in this room, nanomaterials are general purpose technologies. So what are they at a very high level? Most innovations, when you deploy them into an economy, they're impactful to specific parts. You could almost make an argument that they're completely localized. And then you have general purpose technologies. These are the 800-pound gorillas of innovation. I guess in the EU, you would say 360 kilograms. But they have a positively disruptive impact on societies, economies, and the power of government. And so what is a general purpose technology? I think first and foremost is we all have to recognize that they are incredibly scarce resources and they're immensely valuable. Over the last 10,000 years, about 2 to 3 GPTs come across every 1,000 years. This is going back 10,000 years in time. And by the way, I think it's important to note that 75% of GPTs really stem from material innovations because materials are the foundation on which our societies are built. Another interesting attribute is, GPTs tend to enable the discovery of new GPTs. So you could think of the internal combustion engine leading to the automobile, leading to the airplane. And they also have a really interesting quality, which is they don't have competitive rivals. And so what this means is when a GPT diffuses into an economy, it diffuses into every nook and cranny of society and the way that society operates. And last but certainly not least, they give companies the ability to dramatically increase productivity. You could think of things like AI and the implications of AI 10, 15 years out. But really what that allows is companies to win in economic competition And as companies win in economic competition through the tax base, this improves the economic power and clout of a nation. But I don't want you to take my word for it. We're going to just take a quick trip back to the mid-1700s through to the early 1900s. And what we're really looking at here is the two industrial revolutions. So the GPTs at stake at that particular time, we're talking about electricity, the engine, motor vehicles, airplanes. And as these technologies took root, they dramatically altered the societies who took first mover advantage being deploying into the economy. So they increased manufacturing capability, they increased productivity, and they fundamentally altered the trade flows of nations. Now, it also happens to be that certain GPTs, at least, improve war-making capacity of nations. And in fact, war-making capacity through the millennia was relatively flat, but then it took off in the 1800s like a rocket ship. And those GPTs also generated dramatic changes in productivity and economic growth. So much like our war-making capacity, from 1825 forward, global GDP also took off like a rocket ship. And the important thing to note here is it was disproportionate. So as everybody in this room knows, Europe, the United States, we dominated the GPTs of the Industrial Revolution. We reduced them to commercial practice. We did it quickly. We got them into our economies and take that first mover advantage. And so economically speaking, we left the rest of the world in the dust, as you can see here. Whereas over millennia, GDP grows on average 1% year over year, you can just see an exponential curve in terms of the strength, the power, and the GDP of nations. But what you see here is not a unique phenomenon. If you go back throughout the centuries and you look at the rise of every great power, the British, the Dutch, the Spanish, they all dominated the GPTs of their day. And so naturally, you have to ask yourself the question, and this is kind of where I started, what if another country dominated the GPTs of the Industrial Revolution? If we fast forward a little bit, what if the Soviet Union beat us to computing power? What if China invented the internet? I know the question sounds preposterous, but how would that have impacted our industrial base? And what would it have done to our GDP, our tax base? What would it have done to our economic superiority and ultimately our foreign policy posture? And as you spend time and you play out this thought experiment for just a few brief moments, I guarantee you're not going to like what you see. So the important takeaway here is really that the West and its future dominance in GPTs is not guaranteed by the past. It has to be fought for today in the here and now. And so what's at stake for today? Really, in my view, no less than a global innovation race that's likely to shape the West's economic and national security well into the 21st century. Is this race going to be a competition? Is it going to be something more? I don't know. But what I don't think is open to debate is the need to win it and secure that durable economic superiority. So on the table, my view, we have 7 general purpose technologies. Each of them are absolutely critical to the future economic prosperity of nations. And 6 of these have a very strong connection to nanomaterials. Nanomaterials, in a way, is the super GPT, in my opinion. And what I'm seeing now, and I have Russian researchers, Chinese researchers in-house in my company, is that not only is the US and the EU competing here, but China and Russia are competing fiercely to have supremacy in these areas. And China and Russia, because they lean more towards an autocratic system, they can do things that we don't do in the West. They can prioritize their activities, both align it with political goals and economic goals, and they do that through industrial policy. Generally speaking, this is something the West doesn't do, at least until very recently with the CHIPS Act. And so governments like China, they've done really well with industrial policy. We always bemoan that it's inefficient, that it's sloppy, but the reality is they have a long-term goal, and they invest and they invest and they invest until they reach a point where they get economic domination. So we could look at a few examples here. If you look at the PV market, photovoltaic market, for example, after years of investment and also fundamentally structural economic advantages, they have about 85% of the global market share. And if you look at the four parts of the supply chain, the smallest part of the supply chain they have today is about 75% of global manufacturing capacity. And then you look at something like lithium-ion batteries, and today they have 79% of global manufacturing capacity, though this is slated to decline as more of these gigawatt plants come online. So we've established that there are certain peer competitors who are willing to intervene in their economies. By the way, from my perspective, that's their right as a government. They can do whatever they want. But we know that they'll allocate capital to advance national and political goals. We've seen some historical results. And so in the case of China, and really Russia for that matter, they've been targeting nanomaterials really to tip the scale in their favor to their domestic industrial base. And some of those strategic investments, they really are paying off. So briefly, just to talk a little bit about Chinese industrial policy. Many of you in this room have heard of Made in China 2025. If you haven't, it's a state-led industrial policy that's aimed at really rapidly expanding high-tech sectors, reduce reliance off the West. And there is a section of that plan that specifically is dedicated to advanced materials and more specifically nanomaterials, which has become over the years a majority of the focus. At the federal level, now these are 2014 dollars, I expect it's higher, they were spending about $600 million a year in basic and early applied research. It's mostly academic investment. And then when it comes to scale up and commercialization, this is supported through a separate program, which is called the New Materials Industrial Program. There are a few other programs, but this is the dominant one. And the New Materials Industrial Development Program, it's specifically targeted at what they would call frontier materials, and more specifically, organic, inorganic nanomaterials. And China's strategy with this policy really can be broken up into two categories. This comes right out of policy documents from China. So the first is financial support. There is a mandate from Beijing to increase access to capital to the industrial base, establish manufacturing innovation centers, put in place production and application demonstration centers, testing centers, and then, of course, pretty generous tax policy. But the second thing that they want to ensure, and some people in this room are going to be familiar with it, is making sure that the industrial base supports the defense industry, which they call defense civil fusion. And so they've called on, first and foremost, for the Ministry of Defense to guide the nanomaterials industrial base on their needs and requirements. Second, they've started to put in financial incentives to ensure that nanomaterial companies do support the defense base. Third, and interestingly, the Ministry of Defense has been instructed to take technology transfer out of the military and put it into the industrial base, and then also make defense facilities available for testing and a wide variety of other activities. And so the scope of the government investment, quite honestly, is breathtaking. I don't have a lot of time to review this in detail today, but some of the very notable subsidies that are out there for early stage investments, so this is at the venture capital level, there are certain provinces that are now underwriting up to 60% losses on invested capital. If I was a venture capital, I would love that deal. This is just amazing. Very, very, very generous subsidies for office space, R&D space, and manufacturing space, cost of living subsidies, and a whole host of other subsidies, and then tax incentives, which, if memory serves me correct, whatever you spend in R&D, they will rebate you up to 1.5 to 2.5 times the cost, which is pretty significant. And then there are the nanotechnology industrial parks, which I have to tell you really are something that I find to be incredibly impressive. So probably the jewel of this is going to be, I always mispronounce this, Nanopolis. It's one of about 4 or 5 industrial parks across China that are focused on nanomaterials, and it's really targeted mainly at scale up and commercialization. It's not to say that some basic research isn't happening there, but the thrust is commercialization. And so the focus of the center, nanomaterials, nanomanufacturing, semiconductors, and then more recently they added into the remit nanomaterials in healthcare applications, which I think was actually quite a smart move by the Chinese. The platform itself is also staggering. It's a 500,000 square meter facility that has office, R&D, manufacturing facilities. They've actually built pilot manufacturing facilities to help defray cost of companies that are looking to use production equipment without making CapEx investment. And then also, really interestingly, they have a suite of, I'll call it shared services for business. So this is everything from gaining sales and marketing support, logistics support, regulatory support, and even intellectual property support. So filing not only in China, but subsidizing the cost to file abroad. Again, I think a very, very smart move. Now, the center itself, they also separately incubate new companies. And what they do, or their goal really, is to incubate them while they're young and then move them into the park once they've matured. According to the center, every single year they spend about $300 million US, 300 million euro per year just in incubation activities alone. And again, it's coming from the center itself, but how successful have these programs been? According to the park, they have over 780 companies operating in the park. They're incubating 40 to 50 new companies every single year, and they have about 25 to 30,000 people within the campus itself. And in Russia, and some people here will be familiar with this, they also have their own industrial policy. It's a very different mechanism, but it's mainly through RusNano, which is a state-owned venture capital fund. Because of currency fluctuations, it's always very hard to estimate how much capital they've really deployed. But at minimum, they've deployed about $8 billion directly into their industrial base to the tune of about 110 companies. And then separate from RusNano, they also have an incubation program, not dissimilar from the Chinese. And what they've done is they've built 15 really impressive facilities all over the country, including in the East. And to date, they've incubated about 850 companies, and they take on 100 new companies a year. The program is slated over its life to spend about $1 billion, and to date, they've spent US dollars about 450 million. So again, smaller than the Chinese, but still quite impressive. But the important thing to highlight here, and again, there's only so much that one can know when operating abroad versus being in the market. But from what we can tell in all the research that we've done, these activities are all focused, again, not on really academic basic research, but it's on scale up, it's on commercialization, it's about getting product to market. And really, the policies are paying off. I don't have time to get in the details, and I certainly don't want to name and shame companies in these regions, because I think any company would take money if it was given to them through industrial policy. But today, in our view, China is very well poised to dominate the graphene market in the future. I know some people may find that to be somewhat controversial of a statement. And then Russia has already captured 90% global market share for carbon nanotubes. It's not to say that that market is lost, but it's going to be very difficult for either the US or the EU to take any appreciable gain unless there is massive trade policy that just shuts those materials from coming down into the market. Finally, what we can tell from the research we've done is that now, instead of a single material platform, some of the policy focus is changing to the more diverse set of materials. So these are the metals, the metal oxides, the ceramics, the mixed metals. And that's where I expect them to start applying their focus. So where does this leave us? I think it's a good question. The West, so the US, the EU, we're still on top for now. We certainly do have peer competitors nipping at our heels. In my view, China certainly represents the largest competitive threat from a commercial perspective. First, because they have raw talent, but they also have a lower cost basis. Second, China's handling their nanomaterials industry with a whole of government approach, which is very similar to how they've dealt with other industries. And the Made in China 2025 investment plan calls for a focus on nanomaterials. I don't see any reason why they are going to slow down on their investments there. Now, I do have a roadmap out of this. I can't say that it is perfect. I'm sure that many people in this room could expand upon it, make it better. But really, my thesis at its core is that China will be the low-cost producer. And so what that means is we, the West, are not going to be able to compete on cost. And this has happened cycle over cycle, industry over industry. And so the only counterbalance to compete on cost is to continually achieve first mover advantage where cost is less of an issue. And, quite consequentially, first mover advantage is often where the significant value is created. No one remembers the third biggest company in a sector. It's always number one, it's number two that take the lion's share of economics. And so in nanotechnology, to me, first mover advantage really means being able to design a material and scale it rapidly. Largely today, if you look at it's a level playing field, whether it's the United States, the EU, China, or Russia, geography doesn't much matter. We're all sitting in labs designing materials that require expensive people, expensive facilities, and the nature of the work is highly sequential and very empirical. And so how do we get out of that loop? In the short term, I would say what we need to do is we need to find ways to move nanomaterial design to high throughput at first. This would not be dissimilar to what the pharmaceutical community has done over the years with synthesizing drug compounds. I think equally we need to be able to screen for performance of a material on a high throughput basis. I have less of a view on this because our company is not application focused, but I'm certain people in this room have much more informed views on that. And these two areas, I believe that government can make an incredible contribution to the cause. And then there's the question we have to ask, and this is more of a question for industry, which is, should I be trying to manufacture whatever I invent in-house? My strength as a small company, or even a large company, is the industry, the market, the customer, the invention itself. Nano, as everybody here knows, is fraught with scale-up challenges. And so you introduce great risk trying to capture every penny of economics by doing it yourself. And there are companies now, shilling for Cerion, we're one of them, that has been doing this for 16 years, and we know all the pitfalls, and usually we get companies to market quicker. Now, over the medium term, and I definitely don't want to sound like I'm on the chat GPT bandwagon, because I've been saying this since the days of IBM Watson, is how do we cut through the empirical design even more and really move more towards AI-aided design, where I can set a range of specifications for a particular material and get 5, 10, 30 shots on bat the best way to bring that across the line. And then the same goes for performance simulation. Again, I don't have a strong view on that, not being in the application space. And then if you can take that and you pair it with the high throughput, I think you really have a machine where you can drive innovation significantly faster than what we have today. So with that, I've run out of time. Of course, I'm happy to take questions when that time comes, but I appreciate you all listening. I know this is a bit different than some of the other topics we've discussed today, but I hope it invokes some conversation. Thank you.
Thank you.